Hello and welcome back. In this video we will start the last section of Chapter 3, which is on describing relationships between variables. And there's some very precise language that we can use. So for instance, if we're describing the relationship between two variables, we can say things like the variables may vary directly with one another or vary inversely with one another. And these have very precise meanings. When a variable y will vary directly as x, this means that x and y are going to trend in the same direction. Meaning, if x gets bigger, y gets bigger. If x decreases, then y will decrease. So they essentially get pulled in the same direction. Whereas when y and x will vary inversely, when they're essentially inverses of one another, they will trend in opposite directions. So as x gets bigger, as x increases, y will decrease. Likewise, if x were to decrease, then y itself would be bigger. Y would increase. And we can take this and let's look at a couple of examples to make sure that this is making sense. So for instance, if we're driving a car, we can look at how far we've gone, the distance we've traveled, and how much gas we've used. Well, the further you travel, the more gas you use. The less far you travel, the less gas you use. This is varying directly. The distance and the gas will either both increase or both decrease. Whereas if you look at the speed at which you're traveling and the time it takes you to get to your destination, these will vary inversely, meaning the faster you travel, the less time it takes, or the slower you travel, the more time it takes. So these will vary as sort of as opposites of one another. These will vary inversely. So this chapter just looks at taking this information and writing down an equation that will help us determine to answer some questions. So when variables will vary directly, we have the following equation. So when y varies directly with x, we say that y is going to be equal to k times x. And we can see that if x were to get bigger, if we take k and we multiply it by a bigger number, y is also going to be bigger. If x were to become smaller and we take k times a smaller number, well, we will get a smaller number. Y will be smaller. So this is what it means to vary directly. Another way to phrase this is that y is directly proportional to x. So the proportion of x and y will essentially stay the same. As x gets bigger, y gets bigger. As x gets smaller, y gets smaller. This constant k in here, this is just going to be a number, usually not 0. And k is called the constant of variation, or the constant of proportionality. And it tells us if x increases by a little bit, how much does y increase? So if k is, for instance, 2, when x gets bigger, y will also get bigger by a factor of 2. So k just tells us how much they will vary with one another. And to use this information, there's just a couple of steps, and it's pretty natural. We'll write down the equation that governs the relationship. And this constant k, we won't know until we use some information to figure out what it is, plug k back in, and we use our equation to answer the question. So let's dive in with the following. So the number of gallons of water, which is called W, used when taking a shower will vary directly with the time t. So what this is saying is that the longer you take in a shower, the more water you use. The less time you take in a shower, the less water you use. They vary directly with one another. This makes sense. So this means that the gallons of water that you use, is going to be equal to some constant times the time in the shower. And that's it. That's all this first sentence is saying, is that As t gets bigger, w gets bigger. And there's a factor of k that we don't know yet. However, we're told a shower lasting 5 minutes uses 30 gallons of water. Okay, that should help us figure out what k is. And then how much water is used in a shower lasting 11 minutes? Well, just plug 11 minutes in for t, and there's our answer. So a shower lasting 5 minutes uses 30 gallons of water. So if we plug this in, we've used 30 gallons of water in a shower that lasts 5 minutes. Well, this means that I can solve for k. I can divide both sides by 5, and I get that k is equal to 6. So k here is going to be a factor of 6, meaning that for every minute we spend in the shower, we're using 6 gallons of water. Okay, this makes sense. And then how much water is used in a shower lasting 11 minutes? Well, let's write down our equation again, but we'll substitute in what we know. So the number of gallons of water used in the shower is going to be 6 times the time in the shower. And in this case, we want to know how many gallons are used in 11 minutes. So how much water is used is going to be equal to 6 times the time in the shower, which is 11. So we use 66 gallons of water. And I can add my units here for my answer. So that's all there really is to it. We can write down an equation that governs what it means for things to vary directly with one another. And then there will be this constant in here that we can use some information to solve, and we just plug it in and chunk. The next thing is to look at what happens if it doesn't quite vary directly in the way that we mentioned before. So there is another equation here, and when we look at this equation, we see that y is going to vary directly with x to the n. So as x to the n gets bigger, y gets bigger. As x to the n gets smaller, y gets smaller. And we will use this equation when y varies directly as the nth power of x. So there's nothing more to it. It's just the same phrase, except that it's not varying directly as x. It's varying directly as something with an x in it, specifically the nth power of x. We can also use the phrase directly proportional to the nth power of x. So again, nothing new is going on here. Y and x to the n are varying directly. We just have to notice that it is x to the n and not just x. So let's see this in work. The weight of a great white shark varies directly as the cube of its length. So if I call W the weight of a great white shark, and I'll use script L to be the length of the great white shark. What this means is that W is going to vary directly as the cube of the length. So it's not going to be W is equal to KL. It's going to be W KL cubed. So the cube of the length is what varies directly with W. So again, there's nothing going on here. Weight varies directly as the cube of the length. And we're told some more information. A great white that is 15 feet long weighs 205 pounds. So what's the weight of a 25-foot long shark? Okay, so let's figure out what our constant should be. A great white that is 15 feet long weighs 205 pounds. So have 205 pounds is going to be equal to our constant times 15 feet cubed. So if I divide both sides by 15 cubed, we'll get k is going to be equal to 205 divided by 15 cubed. This doesn't really simplify all that well, and I'm just going to plug everything into a calculator at the end. So for the moment, I'm just going to leave this fraction as is. I'm not going to change this. So what was our original equation with this unknown constant in here? I'm going to replace that constant with what we know. This is going to be W is going to be equal to 205 over 15 cubed times L cubed. So all I've done is I've replaced K with what we know it is. And now, what is the weight of a 25-foot long shark? I can plug 25 in for L, and I've got my answer. So W is going to be 205 over 15 cubed times L. So this is the length of a 25-foot long shark, so it's 25 cubed. And this, which we did earlier, is going to be 949 point something something something. So this is just rounded here. So after I put this into a calculator, we get this, and this is the pounds of the, this is the weight of the shark. Just as a quick aside, this is actually very common. Weight will vary directly as the cube of the length of pretty much any object, including human beings. The taller you are, your weight will go up by the cube of your length. And in the next video, we will look at what happens when variables will vary inversely with one another.